All right, friends, it's your boy, Mr. Shady, coming at you with Unit 3, Lesson 5, the size of the scale factor. And so today we're going to be looking at different scale factors and how that affects going from the original to the copy, or from the copy back to the original, and paying really close attention to that pattern that happens. And so in the first activity, we have number talk, missing factors, solve each equation mentally. I'm not going to solve these mentally. I'm going to do the step-by-step process to make sure that we understand what happens. So in order to find out what x is, this says 16 times x equals 176. What I'm going to do is I'm going to divide both sides by 16 to isolate the x there. So I'm going to divide both sides by 16. So now I have x by itself because 16 times 16 equals 1, so we could say that that's 1x. In the future, we're just going to write that as x. And then now we're going to do 176, and we're going to divide that by 16. 16 goes into, cannot go into 1, but it can go into 17 one time. I'm going to subtract 16. I'm left with 1. I bring down my 6. 16 and 16 is 1, so x equals 11 there. So I can see that the scale factor there is times 11, or we're multiplying by 11. And the next one, it says 16 times x equals 8, or 16 times some number equals 8. To remember to isolate x, I'm going to divide again. So I'm going to divide by 16 on both sides. And then I get 1x here, so 1x equals. And then I have 8 over 16. 8 over 16 is a ratio. I know some of you want to set it up as a division problem, or you can see that that's a ratio that can be reduced. So I have 8 over 16. Which can be reduced by dividing both of those by 8. So I'm going to divide 8 by 8 and 16 by 8. And this gives me 8 divided by 8 is 1, and 16 divided by 8 is 2. So x equals 1/2. If you wanted to set it up as a division problem, you can. So you can say 8 is inside and 16 is outside. Remember, that's our Nito and T-bow strategy. Nito and T-bow strategy, top and bottom out, or numerator in, denominator out. So 16 goes in, cannot go into 8, so we need to add a decimal and then add a 0. And then 16 into 80. Well, I know 16 into 80 is going to be 5 times, so the decimal point really should go there, and that's 0.5, or 5/10. So x equals 1/2 or 5/10, and you should know that those are equivalent. Moving on, we have 16 times some number equals 1. Remember, the same process is applying, so I'm going to divide by 16 on both sides. In this process, it's the simplest form that could be. X equals 1/16, right? And then I have 1/5 x equals 1 whole. Now this here, right, so we could divide by a fraction here, or we can know that what is the reciprocal of 1/5? The reciprocal is times 5 over 1. And so we're going to multiply this side by 5 over 1. And then so that undoes that. So x equals 5. And we can check our work with that if we want to. We can also divide. And the same thing happens here. So we're going to do the reciprocal of 2/5. The reciprocal of that is 5 over 2. And we're going to multiply this side by 5 over 2. 1 times 5 is 5. And 2 times 1 is 2. So x equals 5/2. And I'm going to leave it as that form. I don't have to change it to a decimal if I don't want to. So that's the first thing, and it's really just a number talk. It's helping us understand what is happening here, because when we have a scale factor of 5, right, we know that to undo that we could divide by 5. Another way of representing that is multiplying by a 5th. So we're trying to recognize these patterns that exist in mathematics and really truly see what's happening here. And then if, to undo 2/5, we can multiply by 5/2 because that equates to 1, because 5 times 2 is 10, and 2 times 5 is 10. 10 divided by 10 is 1. So let's show that work here just a little bit so that people, can see. So I have 5 times 1, and then I have 1/5. So I want to show you what happens here. So 5 times 1 is 5, and 5 times 1 is 5, and 5 divided by 5 equals 1. So if you want to undo a fraction, right, when a fraction is being multiplied, to undo that you multiply by its reciprocal because it equates to 1. And that's something we've done before. So 2/5 times 5/2, again, you're going to get 10 over 10, and that equates to 1. And that's what you want to do, is you want to get we want to have the x by itself. You want to isolate the x, and to do that, you want it to just be 1x, right? Because that's how you can find the answers to get it by itself. So that's the first activity. The second activity is called a scaled copy card sort. So you're going to be given some cards that look like this tomorrow, and you're going to be given an image and its scaled copy. And it says your teacher will give you a set of cards. On each card, figure A is the original and figure B is the scaled copy. So we're going from A to B. Sort these cards based on their scale factors and be prepared to explain your reasoning. So we're going to look at each one of these and try to organize them by their scale factor, right? So I'm going to look at the first one, card 13. And I'm going to say A is my original, and I'm going to B, so this should be getting smaller, right? So if it's getting smaller, that means that the scale factor has to be less than 1. We've talked about that yesterday. So this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This side is 18, and this side is 1, 2, 3, 4, 5, 6. So if we know that this is a scaled copy, what are we doing to go from 18 to get to 6? Most of you are going to say we're going to divide by 3 here. But really I want us to understand that dividing by 3 is the same thing as saying multiplying by 1/3, because 1/3 is the reciprocal of 3. So when we're talking about scale factor, I really want us to get to that language of saying multiplying by 1/3, because this side is 1/3 of 18. Now I know I only did one side, but I know these are scaled copies, so I'm just really trying to find the scale factor. An easier way, beyond pattern recognition, an easier way is to write the ratio. I would say copy over original, and then you can simplify. Copy over original is 6 over 18, and then I can reduce both of them by 6, and that leaves me with 1/3. So that's another easier way. So I know that this is multiplying by 1/3, so that's one way of organizing that. This next one here, this one looks a little different. We're scaling a circle here, and so we're going from A to B. These almost look the same, so I'm going to count this distance here, this corresponding distance here. 1, 2, 3, 4, 5, 6. So that's a distance of 6. This is a distance of 1, 2, 3, 4, 5, 6. Since those are the corresponding distances, this is a scale factor of 6 over 6, or 1. So that's what I would say the scale factor is for this figure, is 1. So I'm going to put that in a different pile. Then in this one here, we're going from A to B. I'm going to measure this side, 1, 2, 3. Its corresponding side is 1.5. Now, most of us might not recognize that as easily as possible, so I'm going to measure another side, 1, 2, 3, 4, 5, 6, 7, 8. So this is a side of 8. 1, 2, 3, 4. Those numbers are pretty easier to see. So from A to B, we know that we have 4 over 8. Because it's, remember, copy over original, which reduces to 1/2. I also know that this is dividing by 2. Dividing by 2 is the same thing as multiplying by 1/2. So the scale factor for card 11 is going to be 1/2. So I'm going to put that in a different pile. Okay, then I'm going to look at the next card here. The next card I have is this card. And so I'm going to try to find a side that is easiest to measure. And so this one, 1, 2, 3. 1, 2, 3, 4, 5, 6. This looks like a scale factor of 2, so times 2. I do not have a times 2 pile yet, so I'm going to set that off to another side. This one here, this one is 1, this one is 3, so that looks like a scale factor of times 3. I'm going to put that card in a new stack because I don't have a scale factor of 3. This image here, we have, I'm going to measure this line, 1, 2, 3, and that's 1. That looks like it's a third again, times 1/3. I do have a stack for that, so I'm going to find my 1/3 stack. My 1/3 stack is up there. Card 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9, and B is 1, 2, 3. It looks like I'm dividing by 3 or multiplying by 1/3, so this one is also a third. Card 8, I can look for a corresponding distance, right? So I might say 1, 2, 3, 4. That's 4. 1, 2, 3, 4. These look like the same exact image, so times 1. Times 1 I have up here. This card here, have a card here. The bottom of this is 1, 2, 3, 4, 5, 6. 3 times 1/3 again. So 1/3 seems to be a popular scale copy. Card 5. We have 2 circles, so I'm going to calculate the distance here. That's 1, 2, 2, and then 1, 2, 3, 4, 5, 6. 2 to 6 is times 3. So times 3 would be here. And then card 10, I feel like I've seen this one before. Oh, this one's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is also times 3. So then I'm going to organize these. So there's only one with a scale factor of half. Well, that's not times 1/3. I made a mistake there, my friends. That's times 1/2. 6, that's cut in half. Oops, made some boo-boos. 9 divided by 3 gives me 3. Okay, I agree with that. 3 divided by 3 would give me that. Okay. Times 3. Card. Let's make sure that I did this right, my friends, because I have some cards that are in different places. Okay, so what we're going to do is we're going to go through these a little bit to make sure that we know. So scale factors of 2, or scale factors of 1/3. So we're going to start there. Scale factors, and we're going to make sure we review this and make sure that I'm not moving too quickly in my brain. Scale factors of 1/3. So I went from 9 to 3, so that is multiplying by 1/3. So card 6, that does work. I went from 3 to 1, and this is card 4, so card 4 also works. I went from 18 to 6, so that also works. So this is card 13. So those are sorted properly, right? And I didn't make any boo-boos there. And then I'm gonna look at my next card sort. I have scale factor of 1. So scale factors of 1, I had this one. I have card 12 and card 8. Okay, then my next one I had, this looks like a scale factor of times 2. It looks like I'm missing some cards, which might be my problem here. Yeah, I am. Oops, I forgot to do 2. Oopsie. So I have 2 more that I forgot to do, my friends. So in this one here, so this card here, I'm gonna look for, let's look at this corresponding distance. 1, 2, 3, 4. That's 4, and that's 1, 2. So that maybe that's times 1/2. And then from this one, this is 3, 1, 2, 3, 4, 5, 6 times 2. So now I need to organize these times 1/2 times 2. I might have my rest of my cards sorted out. So this one, I have scale factor of 2, or scale factor of 1/2. Scale factor of 1/2. I have card 3. I have card 7. And I have card 11. Those all have a scale factor of 1/2. Scale factor of times 2. Scale factor of 2. I have card 1 and card 9. and then scale factor of times 3. So times 3, I have card 10, card 5, and card 2. So that's what you're going to be receiving tomorrow in class. You're going to organize those. It says examine 10 and 13 more closely. So I need to 10 and 13. I think it's the ones that I said. These look exactly the same. So they want me to examine those a little closer. 10 and 13. What do you notice about the shapes and sizes of the figures? What do you notice about the scale factors? So this one, notice that A is larger than this A, but this A is basically that B, and this B is that A, right? And so in card 13, so the shapes are the same. So what we could say is the shapes are the same. The scale factor on 10 is times 3, and the scale factor on 13 is times 1/3. And so what we really need to pay attention to here is we need to pay attention that when the figure goes from a larger figure to a smaller figure, the scale factor is a fraction. And when the figure goes from something small to something large, it's a whole number, right? And those numbers are reciprocals of each other, like 3 and 1/3 are reciprocals of each other, and so that's another thing to add there. We'll talk about that in class, but I really want us to, get down our thoughts on paper and look at that. So now we need to look at 8 and 12 more closely. So that's 12, that's 8. So in both of these, right, what I notice is that they both are the same, right? So both figures are the same. So in the original, so basically what I mean by that is the original and the copy are identical. And this tells me that the scale factor is 1. This tells me that the scale factor is 1. So if the copy is identical to the original, then the scale factor is 1. And so that's what we're trying to pull out of that activity. The next activity we're going to look at is going to give us some images, and it's going to ask us to draw them again. So it says, what is the scale factor from the original triangle to the copy? Notice that I noticed here that it seems like the grid itself is bad again, so I might have to remake these. So you'll be able to see on here, so I'm going to do my best to recognize this. So this one is 1, 2, 3, 1, 2, 3, 4, 5. That is 5, that's 1. So scale factor would be 1 over 5 because it's, remember, copy over original. So that's my scale factor. I don't need to do any more work than that. The scale factor from the original trapezoid to its copy is 2. And so I want to make sure that I pay attention here. So this, I need to remake these. That looks like it's 1, and that looks like 2. So if I'm gonna do that, I'm gonna double that side. So 1, 2, 3, 4. And then I'm gonna go at an angle there. So I know that has to be 4, this has to be 1, 2. I'm gonna kind of box that in. I'm gonna box this in so that's a little easy for me. So that's 1, 2, I think that's 3 by 3. So 6 by 1, 2, 3, 4, 5, 6. That's really rough. Okay, and then we're going to basically, this is 1. You can't really tell. This is really difficult. So to give you an idea, right, this one came up a little better, but not much better, so I might have to recopy this. So if this side is 1, right, we know that this side has to be 2, and I can't really tell the thing, so I apologize to my friends. I'm gonna do the best I can, so that would be like 2, and then we do like from a 2 to a sort of like this, and then like this, and then like that. So it's just doubling in size. So we should identify that this should be, this is 2, this side is now 4, this side is now 4, this side is 4. And so you have that there. So I apologize for it not showing up the best that it possibly could. And then now we have the scale factor from the original to its copy is 3/2. So now we're going backwards, right? So this one, remember, so if the scale factor going from the original to the copy is this, what is the scale factor going backwards? It would be the reciprocal, so 2/3. So this side is, that looks like it's 3 units long. This side is 1, 2, 3, 4, 5, 6. So I'm gonna take each side. This side is 3, this side is 3, this side is 3. So I'm gonna take 6 times 2/3. That gives me 12/3, which is 4. So I know the longest side should be 1, 2, 3, 4. And then all my 3's, 3/1 times 2/3 is 6/3, which equals 2. So that's 1, 2. That's 1, 2, 1, 2, 1, 2. So that's its original. It's the best I can do. And then here, what is the scale factor from this? Well, these look exactly the same because that looks like at a distance of 2. And that's also a distance of 2. So this scale factor of 1. And then the scale factor from the original figure to its scale copy is 3. This one is a little bit more complicated, so what I'm going to do is I'm going to take, you know, one of these pieces of paper and I'm going to measure this. And I don't want to make that line first because I did that last time and that did not work out for me. So I want to do this like that, and I'm going to do that 3 times. So 1, I'm sorry if you can't see, 1, 2, 3. And then what I'm gonna do is I'm gonna make this other line here, and then I'm gonna connect the angle last because the angle is always the hardest to scale appropriately. So this one is gonna be that 3 times. So let's make sure that it goes past 1, 2, and then I'm just going to take the straight edge. And so this one is really the hardest one because you don't have the grid paper. And so I apologize to the people about not having the grid paper. And so that's a little ugly, but you get the gist there of what I'm trying to do, so I'll zoom out. So that's the last activity for tomorrow. I apologize that you could not see the grid paper. I am going to remake that as we speak. I look forward to seeing everyone tomorrow.